Howdy, math students! It's Mrs. Marcellus and my very wise friend Euclid. In this lesson, we're going to take a look at polygons on the coordinate plane. Today's learning objective is students will find the lengths of sides of polygons by using the ordered pairs of polygons plotted in the coordinate plane. Today's vocabulary is just a review of some words you should already know. Are you ready to give some problems a try, Euclid? Then let's get right to it. In our first type of problem, we want to find the perimeter of a figure by using its ordered pairs. One way we can do this is to graph the figure on the coordinate grid. However, we also want to work towards finding a way to find the perimeter without having to do the graph, because you might not always have a coordinate grid handy. Let's first graph the ordered pairs: 1, 7, 3, 7, 3, 4, and 1, 4. And you can see that that forms our rectangle. Now we can find the perimeter by finding the lengths of the sides. The two vertical sides are each 3 units in length. The two horizontal sides are each 2 units in length. To find the perimeter, we want the distance all the way around the outside, so we would add 2 plus 3 plus 2 plus 3. This gives us a total perimeter of 10 units. If we wanted to find the perimeter without drawing the figure, we could do so by going from ordered pair to ordered pair. If we look from E to F, we go from 1, 7 to 3, 7. The x value changes from 1 to 3, or by 2 units. The difference between 1 and 3 is 2. The difference between 7 and 7 is 0, so we know that we didn't move on the y-axis. Next, let's go from 3, 7 to 3, 4. This would be the side length of 3. The distance on the y-axis changed from 7 to 4, or by 3 units. However, the x's were both 3, so we didn't move at all there. Then let's go from 3, 4 to 1, 4. This is the length of the bottom of the rectangle. From 3 to 1 is a change of 2 units. From 4 to 4 is a change of 0. And finally, to close our rectangle, let's go from 1, 4 back to 1, 7. Since opposite sides are equal, and we have 2 2's and 1 3, we would expect this measurement to be 3, but let's confirm just to be sure. The distance from 4 to 7 is 3, and from 1 to 1 is 0. Now we can add all 4 sides to find that the perimeter of the rectangle is 10 without having to draw a picture. Let's find the perimeter of this rectangle without drawing a picture. We will do so by calculating the distance from point to point. If we go from P to Q, we can see that it is the x value that changes and the y value remains the same. The change in x, or the distance from 3 to 6, is 3 units. When going from Q to R, it is the y value that changes. The difference between 0 and 7 is 7 units. When we next go from R to S, it is the x value that changes. The distance between 6 and 3 is 3 units. Then in order to close the rectangle and add that fourth side, we'll go from S back to P. Here it is the y value that changes. The distance between 7 and 0 is 7 units. To calculate the perimeter, we will then add the 4 sides together. The perimeter of this rectangle is 20 units. If you want, you can always sketch out a graph for yourself. However, this is a much more efficient method of finding the perimeter. Let's find the distance if we walk around this zoo. Each grid square has a length of 200 feet. What is the total distance in feet around the zoo? The first thing we need to do is find out how many units it is around the zoo. We can find the length of each line segment by either counting the squares or using the numbers on the coordinate grid. There are also some ways you can rearrange the line segments to make finding the perimeter more efficient, but I'm going to stick with the basic method for this example. The distance from the entrance to the monkeys is 10 units. Then from the monkeys to the gorillas is 7 units. The gorillas to the elephants is 3. Elephants to tigers is 3. Tigers to the aquarium is 4. The aquarium to the rhinos is 3. Rhinos to the reptiles is 3, and reptiles back to the entrance is 7. Now let's find the total distance. When we add up all the measurements, we find that it is 40 units around the zoo. However, this is not the total distance in feet around the zoo. The problem tells us each grid square has a length of 200 feet. We will next need to multiply 40 times 200. This gives us our actual total distance around the zoo, which is 8,000 feet. We can also solve a similar problem if we're just given the coordinates. Of course, it is always an option to draw a picture, but we can find the answer without doing that. If each unit represents 12 inches, find the perimeter in inches of a garden with these coordinates. Instead of going in a straight line, an alternate way to do this is to stack the coordinates, then work from top to bottom. Let's give that a try. First, let's go from A to B. The x values haven't changed, but the y values have. The difference between 3 and 10 is 7, so it is 7 units from A to B. From B to C, the x value has changed by 6 units. From C to D, the y value has changed by 7 units. Then to complete our figure, we have to remember to go from D back to A. The x value from D to A changed by 6 units. When we add these four sides, we find that the perimeter of the garden is 26 units. However, this is not the final answer. The problem tells us that each unit represents 12 inches. Therefore, we will have to multiply 12 times 26. When we do this, we find that the garden has a perimeter of 312 inches. Let's graph this figure and find the area. Since the figure has 4 points, we know it's going to be some type of quadrilateral. First, we'll start with 3, 3, then we'll go to 3, 6, then to 5, 6, and finally to 8, 3. These dots form a trapezoid. To find the area of a trapezoid, we'll need the lengths of both bases and the height. The length of one base is 2, and the length of the other base is 5. We can tell this by counting the number of squares. Then the height of the figure is 3. We don't really need to know the length of that fourth side because it's not included in the calculation. To find the area, we must first add the bases of 2 and 5 together. We will multiply that times the height of 3, then divide by 2. 2 plus 5 is 7, and 7 times 3 is 21. That leaves us with 21 divided by 2. The area of the trapezoid is 10.5. Since we don't know the specific units, we will add a label of units squared. Hey Euclid, I thought that was pretty fun, didn't you? What's that? Oh, I'm sorry, Euclid. Euclid just told me he's kind of offended that there weren't any owls in that problem where we walked around the perimeter of the zoo. Hey, I know what might make you feel better. How about we go to the zoo now and visit some of your friends? Okay, well, it sounds like we're off to the zoo, math students, so we're going to have to say bye for now.